Okay, so we're here talking about average value over an interval today. And so it says if f can be integrated on the closed interval a to b, then the average value of f on the interval is given by the integral from a to b of f of x dx times 1 over b minus a. The 1 over b minus a is the distance of the interval that we're talking about here. Okay, so if I wanted to find an average, I would add everything up and then divide by how many things I had. In this case, we're going to add everything up and then divide by the width of the interval. Okay, and it will give us the average value of the integral over that interval. So if we look at the average value of f of x equals 3x squared minus 2x, we want the average value over the interval from 1 to 4. So we're going to go from 1 to 4 of the function itself, 3x squared minus 2x dx. And then to find the average of that, we simply multiply by 1 over 4 minus 1. And obviously that's 1/3. And we're going to do this one in the calculator. All right, so we're going to go down to our calculator here, and we're going to pop this guy in. All right, so let's see what we got here. Let's just clear out this window. We're going to go to Math 9. Oops, let me clear this out, because before I do that, I should put in my fraction so that I don't forget it. So I'm going to go to alpha f1, number 1, and I'm going to do 1/3. And then I'm going to do the integral, because otherwise I tend to forget it. Math 9. And so we're going to be going from the interval from 1 to 4. And our function was 3x squared minus 2x. And dx, and if we pop that in the calculator, we get 16. All right, so the average value of this function over that interval is 16. All right, so then it says at what values of x does the function assume the average value on the interval? Okay, so if you look at this, what they're asking here is if we take our average value, 16, okay, and we set this equal to the function. So it says at what values of x does the function, so they're saying f of x, assume the average value. So when does it equal 16 in that interval? Okay, so if we take and we set 3x squared minus 2x equal to 16, and again we're going to use the calculator again. We're going to go back to the calculator and we're going to plot this as y1. We're going to plot this as y2, and we're going to see where those two intersect. All right, so we're going to go back here to our y window. We'll clear these guys out. I'm going to pop in the first one here. So our first one's going to be 3x squared minus 2x. And our second one is simply going to be 16. We're going to hit graph. And we're going to find out where do those two guys cross. All right. Now, I should have known this because my window only goes up to 10, so I'm going to have to adjust my window. I need some more y values on the positive side. So I'm just going to come down here and change this to 20, and then I'll go back and graph it again. And it didn't change it. Why is that? Window. Oh, because I did it on X, not Y. All right, doing great here. I'll just change that to 5. How's that? Let's try a Y max. I need a Y max of 20, not an X max. All right, here we go. Maybe we got it here. There's 1, there's 2, and there we go. Now you can see that it intersects the parabola twice, but the left-hand one is somewhere over around -2, and so that's not in my interval from 1 to 4. So they're asking, you know, where is it in the interval? That's the right hand side here. So we're going to find that. We'll go to second, calculate. We're going to calculate the intersection, number 5. And so we need to get up to our graph there. Okay, we'll hit enter, enter, enter. All right, so it looks like we're intersecting at 2 2/3 or 2.667. Okay, So our value here is x equals 2.667. Okay. All right. Find the average value of f of x equals cosine x on the interval from 0 to pi halves. Okay, well, once I know where the interval's at, that helps me set up my integral. So I'm going 0 to pi halves of cosine x dx. And we want on the interval from 0 to pi over 2. So this is going to be 1 over pi halves minus 0. Okay. And again, we're going to use the calculator to do this. And so we'll go back here. We're going to go back to the home screen. And we'll clear all this stuff out of here. We're going to go to Math 9. And we want to go from 0 to pi halves. So we'll do pi divided by 2. All right. And we need cosine of x here. And dx. And guess what? What did I forget in the front? I forgot my fraction, didn't I? So I can always put it at the end. It's not a big deal. But again, that tends to be one of those things that I forget about. So I'm going to want to multiply that by, and come on, where's my f1? Alpha f1. And pi minus 0 is just pi or what do we got on the denominator there? Pi halves. So I got 1 divided by pi halves. Pi divided by 2. All right. So it looks a little funky, but that's all right. It'll still give us the same answer. And we're going to get this nice little decimal value here. Now, if you look at the next, now one thing I do need to mention here is that when you go to do this, if you're dealing with sine and cosine, your mode needs to be in radians. Mode in radians. All right, and our value here was 0.6366197724. Why do I want all that? Because the very next question says at what value of x does the function assume the average value? So what I'm going to do here is I'm going to store this. I'm going to put that in my calculator and I'm going to store it as a. All right, and then what I want to find out again, at what value of x does the function, so where does cosine of x assume the average value? Where does it equal 0.6366197724? So by having this in here, by storing it in the calculator, so I'm going to go back and do that. So I'm going to go to my, we'll quit out of this one. I'll go back to my main window here. We'll hit X and enter. And then I want to store that into alpha A, enter. And so now I've got it stored. And the reason I'm going to do that is because, again, I'm going to graph y1 and y2. And then I don't have to type in that whole number again when I go to graph it. Okay? So we're going to look at y equals, here we go. So we'll clear this guy out. We'll just put cosine x in. Cosine of x there. And the next one, we'll clear this out. And we'll go to alpha A, and then I'm going to go to zoom here because, or window, because cosine maxes out at 1 and -1, so I really don't need all of this. And our interval is 0 to 2 pi, so I'm just going to put in 0 to pi halves. So I'm just going to literally type that interval in. 0 to pi divided by 2, that's on my x-axis. And then my y, I might do -2 to +2. And we'll go ahead and graph this. That way all I'm looking at is the interval that is mentioned in the problem. Okay? And of course it didn't graph A for me. Why didn't it graph A? Oh, you know why? Because I didn't store it. I've got to hit store alpha A. For some reason it didn't. Let me try this again. Store. One more time here, guys. Alpha A. All right, let me go back to my y equals window, and I'll just retype this in alpha a. I'm not sure why it's not doing this. Here's my first graph. Okay, so I'm not sure why it's not typing that in there. I'm gonna have to figure out what's going on there. I'm hitting something wrong here, but I can. That's why I always want to write down the number, because now I can go back and I can just do 0.6361977724, and I can graph like that. There we go. Here's our first one. There we go. And so I need this intersection over here on the right side. So we're going to go alpha, or yeah, we're going to go, oops, wrong one, clear. We're going to go second, calculate, number 5. And so we need the intersection here. Oh, we're pretty close already. Okay, so we'll hit enter, enter, and enter. And it looks like we are at 0.881. All right, so x is going to equal 0.881. All right, that's pretty straightforward, isn't it? Okay, what is the average value of the function f of x equals this nice little beast right here on the interval from 0 to 2 pi. So now I'm going to have the 1 over 2 pi minus 0. So again, I'm just subtracting the two values in the interval for my average. We're going from 0 to 2 pi of 9x squared plus cosine of x. And this whole thing is being raised to the third power. All right? So now we're going to take this, pop it in our calculator. So we'll come back over here. I want to remember my fraction, so that's going to be 1 over 2 pi. So we'll pop that in there, and then get out of there, and we'll go to our integral, math 9 again, and we're going from 0 to 2 pi. Oops, forgot my 2. Oh, crud, come on. Try this again. Hit the wrong buttons and you lose everything. 2 pi. Math 9. 0 to 2 pi. Painfully slow when you're trying to type this in on the computer here. Alright, so we've got, alright, we need some parentheses for our 9x squared. So 9x squared plus cosine x. We're going to close up the cosine x. We're going to close up the 9x squared. We're going to raise this to the third power. And finally, dx. All right, and we get 6440521.741 as our answer here. All right, so this is going to equal 6440521.741. Okay. All right. I'm going to stop and get a drink of water here. All right, so we're back with our last one here. It says if v of t equals 1 over 1 plus t cubed, then find the average velocity of the function on the interval a to b. So again, when we talk about average velocity, okay, average velocity is simply the position function. All right. So we talked about average velocity in our last unit, and we talked about the average over average velocity being the integral. So let me actually write this out. So if we're looking over the interval from a to b, that means that the integral from a to b of v of t, so this is 1 over 1 plus t cubed dt. we know that this integral here is equal to the position function x of b minus x of a. All right, so that's what we talked about in our last unit, was the fact that those two are equal to each other. The fundamental theorem of calculus says that if I want to compute this integral from a to b, I can use the position function or the antiderivative using the limits of a and b. Now, to find the average value, as we talked about today, we know that if we take this integral and we multiply this by 1 over b minus a, that would be the same thing as multiplying this right side by 1 over b minus a, which is simply b minus a. All right, and again, the reason we know that is because of the fundamental theorem of calculus tells us what's in the purple, and taking the average on both sides of the function keeps the function equal to itself when I do the same thing to both sides. Okay, so in the next part they actually give us some limits on this, so let's take a look at this one here. Where am I at here? There we go. So they give us if a is equal to 2 and b is equal to 4, then what is the average velocity? So now we're looking at the integral from 2 to 4 of 1 over 4 minus 2, and this is of 1 over 1 plus t cubed dt. So this should equal, and we're going to need a calculator for this because we can't do the integral of this guy, and so we'll go back to our calculator again and we'll find that integral right there. So we're going to go pop this in. So I'm going to start off with my fraction again so I don't forget that. So I'm going to do 1 over, and the interval was 2 to 4, so we're going to go 1 over 2, and then we'll do math 9 again for the integral, and we're going to do 2 to 4 here as well, and then we're going to pop in yet another fraction. All right, and the top of our fraction was 1, and the bottom of our fraction is 1 plus x cubed. Come on, all the way out. There we go. And if we pop that in, we end up with 0.044 as the average value, equals 0.044. So the average velocity would be 0.044. Okay? So hopefully that makes a little bit of sense with what we talked about earlier, and have fun with the homework today. All right, bye-bye.